Today we are going to be talking about a very special element in all of our lives that is necessary to life itself, and it goes by the name carbon. In fact, it is so important to human life, it actually makes 18% of our makes up 18% of us. So the others, there's 65% of it is water, and I'm not sure what the rest of it is, but the point is, it's important. Now you might be wondering, where could I just find such a wondrous element? Well, it's everywhere. I mean, it's in your pencils that you use to write stuff. So, pencils. Oh, hold on. I know. Ugh. Okay, forget me trying to draw a pencil. Point is, it's in pencils, it's in diamonds, it's everywhere. It's in propane, it's in butane, whatever that is. It's everywhere. Now, there's a reason why carbon is so special. So first of all, let's pull up our handy-dandy periodic tables so we may look at some of the reasons why it is so very important. Not this one, hold on. There's one I actually have downloaded on my computer. If you've been watching my videos for a while, you'll know what I mean. Let me just check my files if I can get there. I know it's somewhere in there. So yeah, let me find it. And new. Here we are, our periodic table that is oh so very important. Just let me close this. I know it's a bit crowded. Just patience, please. Okay, never mind. I can't shrink this. The point is, let's look at it. So when we look at its place on the periodic table, it's in the non-metal elements part of the table. And carbon has 6 protons and 6 electrons. 2 in its innermost shell. So wait, let me draw it. I can do it. I can do this. So first shell. Now, electrons do not go in orbits; they go in orbitals. So they're just randomly bouncing around, and you just have to hope to find them. I mean, it's like a probability cloud, and like they're probably here. Not saying that they are, but they probably are. So here's our first 2 little electrons. Now let me switch back to black, and we'll get on that. You know, I wonder why WebPaint has a bunch of different coordinates just for black when it's all the same color of black. It makes no sense. Seriously, like why? What even is the point? But anyway. Let's see. I know this is probably not the same color, but I don't care. I'm just trying to draw this for you guys. So, yeah, and it has 4 valence electrons. So it can form 4 bonds. Count them. 4 with other atoms. So, yes, very special. And this is why it's so strong, because it can form double bonds where I think it shares 2 of its electrons with something. So, like, it could do this with something. I don't know. Use your imagination on what this is, but yeah. It can also just form 4 bonds in general, and you'll see it form whenever people talk about carbon and they show bonds and stuff. They're usually gonna and carbon chains and all that. Hydrogen is bound to be involved. It just is. Tia, did you have to come in here and burp during the middle of my video?
I didn't
know you. Okay, anyway. Yeah. Hold on. So, wherever carbon, so hydrocarbons are important, but I'm not exactly sure why yet. I'm still learning about this myself. Tia, you can't eat in here. Okay. Tia, you're not allowed to eat in there. So, okay, anyway. So yeah, you'll usually see it with hydrogen or other carbons. However, it can form a lot of different things. So I guess we should go look at some different types and try and draw them ourselves. That seems like a boatload of fun. Yeah, no. Okay. So let's go look for some. Wait. Yeah, okay, we'll be fine. So, carbon. Let's go look for some hydrocarbons. Hydrocarbons. Here we are. Okay, so let's look for some. Ooh, and here are some. So there's this one called methane. So it's one carbon and 4 hydrogens. By the way, I know you're wondering, how did I even get to this blank site just so I could do all of this? It's just called blank.org. Probably be useful because I don't know, I don't have any like painting softwares where I could just do that, so I have a paint extension called WebPaint. You probably already knew that, but anyway. So let us draw ourselves 1 carbon and 4 hydrogens, and this together. Okay, so wait. One thing that I might need to explain to you is, in case you're new to chemistry and all of that, pretty much most atoms like to feel like they have 8 electrons in their outer shells to be just like the noble gases. They're so cool, they don't interact with anyone, or most of them anyway. I won't tell which one, but in a book I read, apparently xenon was caught interacting with another atom or molecule or whatever. Oh, yeah, I don't know. I mean, I know what happened, I just don't know with what, but yeah, xenon was interacting with something, so that's a shocker. But anyway, my horrible attempts at electrons are right over there, and my hydrogens, so yeah, pretty much. Now, since they're sharing, this is called a covalent bond. They're sharing the electrons. And hydrogen feels like it has 2, so helium and hydrogen are both exceptions to this. They just want 2. That's all they ever wanted was 2. They don't even care about getting like 8. So so remember, helium and hydrogen only want 2. Everyone else just wants 8. So hydrogen feels like it has 2. The other 3 hydrogens feel like they have 2 as well. And carbon feels like it has 8 now. So yeah, back to drawing methane. Now, we should probably find out what methane is even for, because, I mean, I'm just here talking about why carbon is very important to life, so. Most types of molecules that carbon is in are called macromolecules or organic molecules, which are pretty much, because carbon is just that interconnected with life. So.
I need help.
Not now, so I'm in the middle of a video. Ask Tia or something. So, yeah, so let's just. So let's find out what is methane for. Now, I know why propane is used. It's because when the bonds between hydrogen and carbon break, because they're so strong, they release a lot of energy. In fact, carbon is in like plastic, petroleum, and a whole bunch of other stuff. And that's because it's very high energy, which is why it's probably used in life in the first place. Should have mentioned that first. So methane is a colorless, odorless, tasteless combustible gas. It's also poisonous, and it's pretty. And it says it's inert, but whatever. What I should have looked up. What is methane for? Not formula. What is that? Let us go find what methane is for. What are the main uses of methane? So it is primarily used as fuel to make heat and light. It's also used to manufacture organic chemicals. Methane can be formed by the decay of natural materials and is common in landfills, marshes, septic systems, and sewers. So yeah, well, anyway, goodbye. And thank you for watching. I hope you learned at least something from about